All right, let's start with something called factorials, which kind of bridges into permutation combinations. Have you done this in class? Yeah, so I don't think it's terribly difficult. So was my thing acting weird? Let me try that again. Okay, let's talk about factorials. So you can do this on a calculator as well. The symbol for factorials is an exclamation mark. For example, 1 factorial is simply 1. 0 factorial is also 1. But 2 factorial is 2 times 1. So you got to bring this down all the way to 1. 3 factorial is 3 times 2 times 1. 4 factorial is similar. 4 times 3 times 2 times 1. You get that? What you can do is you can make it complicated. For example, what is 10 factorial over 6 factorial? So let's try solving this. So 10 factorial is 10 times 9 times 8 times 7. Okay. Because there's a 6 factorial on the bottom, I'm going to rewrite the numerator in terms of the 6 factorial. So this becomes times. Either you can do 6, 5, 4, 3, 2, 1, or you can simply do 6 factorial because this is 6 times 5 times 4 times 3 times 2 times 1. And in the denominator, you have 6 factorial. What you can do is these things can cancel out. So this cancels out with this. So the final solution is this. You plug that in a calculator, and that will give you a number. 10 times 9 times 8 times 7, which is 5040 for the final answer. So factorials by themselves is it's pretty easy. Let's see what the next thing is. Just keep in mind that 0 factorial is 1. So now we have combinations and we have permutations. In permutations, the order matters. The matter at which you pick stuff, it matters. Whereas in combination, the order does not matter. And they both have different formulas. So the formula for combination is this. We're going to do a quick example for both of these right now. We're going to do, so that's the formula for combination. C is combination. N is your sample size. So what's the total number of items you have? X is how many items are you picking? So let's do a quick problem with this one. I'm just going to steal their example. So let's look at the hardest part about this is deducing whether or not the order matters or not in the question itself. So an ice cream parlor has 6 flavors. So that doesn't matter which one you're dealing with. That means the N is going to be 6. And Kristen wants to buy 2 flavors. So you're picking 2 items. Your X value is going to be 2. You're picking 2 items from 6. If she randomly picks 2 flavors out of 6, how many possible combinations are there? So now think about it. There are 6 ice cream flavors. 4, 5, 6. We want to pick any 2 randomly. Does it matter? Does the order matter? No, you can pick the first third, you can pick first second, you can pick first sixth. The order does not matter. When the order doesn't matter, you're dealing with combinations. They won't say it in this question. In this question, they do. When the order doesn't matter, you're dealing with combinations. So for the final answer, we're just going to use this formula. So n factorial, that's going to be what, 6 is your n, divided by x factorial, so that's going to be 2 factorial. And in a bracket, you have n minus x, so you have 6 minus 2 factorial. So this becomes 6 factorial over 2 factorial, 4 factorial. Now you can either plug this on a calculator or we can kind of deduce this. 6 factorial is 6 times 5 times 4 factorial. 2 factorial is just 2 times 1, that's just a 2. And 4 factorial, I'm going to write that as 4 factorial so I can cancel this. So for the final answer, this thing and this thing cancels out. You have 30 over 2, so the answer is 15. So there's 15 total combinations of picking 2 items out of 6. Did that make sense? This is everything is the same. So the hardest part about this is, like I said, you have to identify whether something is combinations or something is permutations. The only difference is that in permutation, the order matters. What does it say here? Yeah, the order of selection is important. So the formula changes slightly. But this is a formula for permutations. The only difference between them is in the denominator, you are no longer dividing by x factorial. It's just n minus x factorial. So let's look at a question. A club has 20 members, so that's your n value. They are to select 3 office holders, president, secretary, and treasurer for the next year. So n is 20, x is 3. You're picking 3 items out of 20. They always select these office holders by drawing 3 names randomly. The first person becomes the president, the second becomes something else, the third becomes something else. Does order matter here? It does. So now you're dealing with permutations because now the first pick becomes the president. So it's not like the second pick can also become the president. So the order of selection is important. We're in the permutations zone. So how do you solve this? Again, it's very simple. 20 factorial divided by n minus x. That's going to be 20 minus 3 factorial. So this becomes 20 factorial over 17 factorial, which is 20 times 19 times 18 times 17 factorial over 17 factorial. This cancels out of this. So the final answer is going to be a number 6840. And that's the final answer for this question using permutations. How deep did you go with this? What else did you do? Okay, let's do a pop quiz. A ski patrol has 9 members. 2 of them are to be sent. How many ways is this permutations or combinations? There's 9 people. We want to send 2 to the rescue. Nowhere does it say like the first one is like the captain or whatever. Yes. B, ice cream shop has 25 flavors. You want to pick 2 flavors from the 25. Is that permutations or combinations? Right, I know here it says permutations because they're forcing you to, but it won't say this on an exam. It'll always say how many arrangements are there. In that case, you're picking 2 out of 25. It doesn't say the first 2, last 2. The order is not that important. That would be combinations. The next one, we have 12 horses. We have to pick 3. And again, this is very simple. It's going to be combinations. An agency wants to select 4 houses from 25. That's going to be combinations because nowhere does it imply any order. 545. Investor will select 6 stocks from 20. That's again no clue here about any order. If it says arrangements, then this is going to be combinations. The next one, 16 workers, and then we're selecting 2 workers out of 16. That's going to be combinations. In how many ways can a sample without replacement of 9 items be selected from a population of 20 items? Is that permutation or combination? We're selecting 9 items out of 20. Exactly. The next one's also going to be combinations. Now, if you notice the formulas, right? Let's do a random example. Which one do you think is always going to be bigger between these two? Let's go back to this question. So the answer here was what? I'm going to redo it. N here was 6. We're selecting 2 flavors, so X is 2. So let's see, if this was a combination, which this one is, it'll be 6 factorial over 2 factorial or times 4 factorial. I think this was 15. I'm feeling lazy. I'm just going to plug this in a calculator. Um, 2 factorial times 4 factorial, that's going to be 15. But now if you do permutations, it'll be 6 factorial over 4 factorial, which is 30. So what does this mean? Which number will always be bigger? Permutations will always be bigger than the combination because for permutation, you're not dividing by an extra digit in the denominator. Whereas for combinations, you are. So in permutations versus combination, the number of arrangements through permutations will always be larger than the number of arrangements through combinations. And usually the question is going to be combinations in real life anyways. But again, you want to pay attention to whether or not the order matters or if it does not matter. Cool? We'll come back to this tomorrow. Let's finish what we were doing yesterday as well, because that's the end of the question. That's as hard as it gets for first year university. That's where this book is from. But I know it can get more difficult. So where did we stop yesterday? We were here. Use synthetic division to divide this. You think this is difficult? How do you do synthetic? Have you actually done synthetic in class? How does it work? Not worry about it? Okay. But it's not that difficult. I think it's much easier, especially when the divisor is linear, right? So what's your k value? What's going to come on the outside? -2. And then you want to put all the leading coefficients. And then again, pay attention to whether or not anything is missing. Is anything missing here? Any power? Power 1 is missing. So what you do with that is you write a0x, then -5. In synthetic division, you're always adding stuff. This number always comes down as it is, 2. Then you're going to cross multiply. -2 times 2 is -4. Add 1. And again, cross multiply. -2 times 1 is -2. Add. So that will become -2. Multiply. It'll become 4. So the final answer is going to be your quotient. It's always going to be 1 power less because you're dividing a cube by a linear function. So your quotient is always going to be, in this case, it'll be x squared. So your quotient is 2x squared plus 1x minus 2, and your remainder is -1. Does that mean it's a factor? It's not a factor. Okay, fully factor this polynomial. How do we do this? How would you do this? What's your approach? Mhm. So that'll be +(-1), +(-2), +(-4), +(-8). Can you see it? One of them is gonna work. Is +1 gonna work or -1? Because if this is a 1, this is a 1, that's an 8. That's gonna add up to 10. Yeah, positive one's gonna work. So does that mean x plus 1 is a factor? Does that mean x minus 1 is a factor? X minus 1. So let's factor this. So x minus 1, we're gonna do long division now. On the inside, we have the dividend of x cubed. Again, pay attention if anything is missing. If it was, we'd write it as 0x squared or something, but here nothing is missing. What goes up top? X squared. So you have x squared times x cubed, x squared times minus 1 minus x squared. You subtract this and this cancels out. That's going to add up to 2x squared. Whenever you subtract something, you're allowed to bring the next digit down, minus 10x. What goes up there? Plus 2x. Then you have 2x times x, 2x squared. 2x times negative 1, negative 2x. Subtract, that cancels out. This becomes a plus. Negative 8x. What goes up top? Negative 8. So then you have negative 8x plus 8. So the remainder is 0. So that means it's a factor. So what's next? It says fully factor. Are we done? So what's next? Right, right. So for that, let's man that. We're looking for two numbers that multiply to a quadratic, that multiplies to negative 8 times 1, negative 8 adds to positive 2. Do those numbers exist? Negative 4 or positive 4 and negative 2? Yeah, yeah. So therefore, P of x is going to be your divisor x minus 1 times this thing factored out. So that's x plus 4. Sorry, that's x minus 4. Would it be x plus 4 or x minus 4 in here? Plus 4 and x minus 2. And that's it. Not that difficult. This is the same question. I'm not going to waste time on it. Have you done inequalities? I wonder why not. Okay, we're going to skip that. All right, so how do we solve log problems like these? So the question is asking us to simplify it. The final answer is simply going to be a number. How do we do A? Or is that the final? Oh, you just plug it in a calculator. What's the approach? No, you have to simplify this. I don't think you need a calculator for this. Maybe you do. So what you need to do here is you need to remember the log rules, right? There's three of them. So this one's you have to use the product rule of logs or the multiplication rule. Because they're being added, they have the same base, you can combine them. Remember, this is the thing. Log A plus log B is log AB. Log A minus log B is log A over B. And then there's the power one. Log A to the power of K is K times log A. Have you done this in class? Okay, so for part A, you've got to use the first rule. That's just going to give you log base 5 of 28, right? Now to plug this in a calculator, some calculators come with predefined bases. If they don't, what you got to do is you got to split this apart. This is called converting to base 10s. Log base B of A, you can write this as log base 10 of A over log 10 base of B. So this is how you'd plug it into a calculator if it doesn't have the base function. So here you do log 28 over log 5 for the final answer. Okay, let's look at the next one. What's going to be the approach for B? Again, it's the same idea, right? The 2, let's worry about this 2. Where does that go? It becomes an exponent. So you have log of 8 squared or 64 plus log of 2 minus log of 4. These two are going to multiply. This one we're going to divide. So let's combine them into one big log. So it becomes log 64 times 2 over 4. This goes into the 16 times. So the answer is log 32 on a calculator, whatever that is, done. What about C? How do we simplify that? That one looks a bit tricky, right? So what you want to do with that one is you want to use the base conversion rule, this one. Right now we're here. We want to move it back here. The denominator becomes the base. So in the denominator, you have a 4. The 8 is irrelevant. You can write this with any number. Base 10s is the default, but this works with any number. So I'm gonna make a note of that. Maybe put K and K here. So here, what we're gonna do is, because they have the same bases initially, the denominator is gonna become the base. So log base 4 of 80. Using this rule, going this way though. And then if you want to plug this in a calculator, you can plug it in like this, or you go backwards into base 10s, log 80 over log 4. And there you can't use the multiplication rule, be careful, or the division rule. It has to be one log with two numbers inside of it, not two logs. Okay, we have a log equation. How do we solve this one? Any ideas? Yes. So log of, what's that? X squared minus X. What's this? Okay, what's next? Yes. So now to solve a log equation, you convert it into exponents. To solve an exponential equation, you convert it into logs. So here we're going to use log base A equals C. We're going to convert it into B to the power of C is A. So here there's an invisible 10, which is our B. So this becomes 10 to the power of 1 equals, or I can also write it on the other side. 10 to the power of 1 equals, the log disappears. Now move everything to the same side. We're just dealing with a quadratic. Okay, do these numbers exist? Multiply to negative 12 and add to positive 1. Do those numbers exist? Yes. So then you have x plus 4, x minus 3 equals 0. So therefore x is negative 4 or it's positive 3. Are those both valid answers? No. Which one is invalid? Yes. Because if x were to be -4, you'd get a log of a negative number, and you know the log function cannot cross this. You cannot be on this plane unless there's some sort of a transformation. If there's this transform, if there's a reflection on the x-axis, if you have log of a negative x or something, if there's a transformation, then only, otherwise no. Cool? Okay, what about this? What's the approach for this one? Mhm. So what would be the next step? It's the same, but the only difference is the base is different. Keep that in mind. What's the base of a ln function? It's e to the power x, okay? E to the power, whenever you have a ln question, your base is e. If you have a log question, your base is 10. That's the only difference. So here, we're just going to do what we did in the last question. The base to the power of this is equals to this. So here, it's going to be e to the power 6 equals 2x minus 10. And e to the power 6 is just a number. It's like pi to the power 6. So here, it'll be e to the power 6 plus 10 divided by 2 would be your x. So we can plug that in a calculator. Um, so e to the power 6 is 403, yada yada, plus 10 divided by 2. So x, I'd be okay with leaving it in this form. If they wanted in decimal places, it'd be 206 plus 714 for the final answer. And you're done. It's just a two-step thing, not that difficult. Okay, this one, what's the approach? So what would that be in this case? If you can. If not, you're gonna have to use logs. But in this question, maybe we can. What's a common base? 2. Right, right. So it'll be 2 squared, that's 4, to the 2x minus 5 is equals to 2, 3x. So it'll be 2 to the 3x. What's the power of 2 on the left-hand side? 4x minus 10 is correct. What's next? Right, so it'll be 4x minus 10 equals 3x, x equals 10. Done. What about this one? Could you ln both sides instead of logging? The answer is yes. Well, we're not going to do that because log base 10s is just easier to deal with. E is like a irrational number. We don't want to deal with this if possible. We want to deal with the base 10s. It's easier to deal with, but you could definitely take lns on both sides and give an answer in terms of ln. So this would be log of 3 times x plus 5. The exponent comes outside. 2x minus 1. Exponent comes outside. Log of 5. Okay, what's next? So x log 3 plus 5 log 3 is equals to 2x log 5 minus log 5. What's next? Hmm. So let's see what's gonna be easier. I'm gonna move this to the other side. I'm gonna move this here. So you get 5 log 3 plus log 5 is equals to 2x log 5 minus x log 3. What's next? Right. So it'll be x2 log 5 minus log 3 is equals to 5 log 3 plus log 5. So x will be 5 log 3 plus log 5 over 2 log 5 minus log 3. And that's going to be the final answer. Exactly. You're welcome to plug it in a calculator if it asks you for decimals. Have you done trig identities? Okay, hold on. When you say yes, I'm talking about this one. There's something called double angle identity. Sine 2 theta is 2 sine theta cos theta. Have you done this? Right, right. So this is called the double angle formula for sine. For cosine, there's 3 different formulas. Let's not get into it. This question is asking us for sine. So how would you approach this problem? It says state an exact value. What they're telling you is put your calculator away. It's not going to help you for this problem, is what that means. Sketch it out. Which quadrant are we in? Second one is right. So what you want to do in a question like this is you want to draw a triangle. Remember what sine is, SOHCAHTOA. Sine is the opposite over the hypotenuse. So in the second quadrant, let's draw a triangle. It's going to be a right angle triangle. This angle is going to be theta. That's the principal angle. We don't know what that is. This angle is going to be alpha, the related acute angle. And from the perspective of this angle inside the triangle, you can also put alpha up there. Actually, no, you can't. Alpha always has to be from the horizontal, right? You cannot put alpha up there. The related acute angle in any quadrant must come from the horizontal, like this, like this. So alpha will always be in one of these 4 positions. So what are the dimensions of this triangle? Do we know any side lengths? Yeah. And the opposite is 21. How do we find the other side? It'll be 29 squared minus 21 squared. So it's 20. So that's step number 1. Now we're just gonna go into this formula. Sine theta. So again, cast rule, C-A-S-T. Sine theta is the exact same thing as sine alpha. On the other hand, cos theta is negative in quadrant 2, so it's the exact same thing as negative cos alpha. So sine alpha in quadrant this, again, I'm looking at the triangle. It was also given in the question, 21 over 29. Cos alpha is going to be negative 20 over 29. So now for the final answer, we're just going to use that double angle formula. So therefore, sine 2 theta is going to be 2 times sine theta. So this is what it came out to be, 21 over 29 times cos theta is going to be negative 20 over 29. So 2 times 21 times negative 20 divided by 29 squared. It's some number, negative 840 over 841 for the final answer. Did that make sense? It's not that difficult. Just sketch it out and work with the ideas of the related acute angle. You have to do this, especially when asking for an exact value. Calculator is not going to help you. I guess it could help you multiply these numbers, but it won't help you come up with these digits. Oh, this one's really difficult. You have the formula sheet with you? We can pull it out. So let's go back here. Let's go back here. Which one do we need? I want one with like a nice graphics. I guess that will do. So like I said, this question is difficult because it kind of makes you think. Which quadrant is 7 pi over 12? I ask, is it bigger than point 0.5 pi? Is it smaller than 0.5 pi? I guess that's one way of looking at it. It's bigger. So which quadrant are we in? Yes. Um, Give me a second. All right, back. This angle is 105 degrees. You can just plug that as 180. It says exact value. When it says exact value, we're dealing with the special triangles. Or, like in the previous question, they will give you dimensions of a triangle and you can work out everything else. If they don't give you any numbers, that's a hint that they're asking you to use the special triangles. Now, for the special triangles, we only have 30, 60, and 45, 45. Right now, the angle is 105, right? So what you need to do is you need to write this angle in terms of two other special triangle angles. Here's what I mean by this. For example, if they ask you for what's a good number? I don't know, like I guess we can just do 120. You can write that as cosine 60 plus 60 because both of these are special triangle angles. What about 105? How can we write this in terms of two special triangle angles? One of them is 60. What's the other one? 45. You see it or no? Because 105 is not a special triangle angle. We can't work with it. We need to rewrite it in terms of something that we can work with. So one combination would be 60 and 45. Because we're dealing with radians. 60 is what in radians? Pi over what? 346. 60 is pi over 3. What about 45? 6 pi over 4. And now, only now, you can use the compound angle formulas. So now be careful, the sign in the middle matters. Right now we're dealing with a positive cosine, so we're here. So what does that translate into? So it says, I'm just going to follow the formula. This is your A value. The first angle is your A value. The second angle is your B value. So I'm literally going to follow the formula like this. It's going to be cosine of pi over 3 times cosine of pi over 4 minus sine of pi over 3 times sine of pi over 4. So now you draw your special triangles however you want to. The pi over 4 ones is pretty simple. It's 1, 1 root 2. Pi over 6, 1, 2 root 3. So there you go. Those are your triangles. Probably have them memorized by now. You should. I'm just gonna follow the use. What's cosine of pi over 3? Pi over 6 is 30. Is it the opposite of sine 30 is 1 over 2? I think you're used to writing it this down, this up there. But let's see if that changes anything. Okay, let's do it like this. 30. Now I've written that angle down here, 60. The hypotenuse is going to be 2. What goes on this side? What goes on this side? It's the same thing, right? It's the exactly, you can write it up, down, it doesn't matter. Cosine of pi over 3 is 1 over 2. I'm just looking at the triangles. Cosine of pi over 4 is 1 over root 2. Sine of pi over 3 is root 3 over 2. Sine of pi over 4 is 1 over root 2. Now you multiply 1 times 1, 1 over 2 root 2 minus root 3 over 2 root 2. So you can write this as 1 minus root 3 all over 2 root 2 is the final answer. What sometimes they ask you to do is they're going to ask you to rationalize the denominator. Right now there's a 2 root 2 element down here. How do we rationalize this denominator? Right. So multiply root 2, multiply root 2. Um, so it'll be root 2 minus root 6 over 2 times 2, 4 for the final answer. And you are done. Cool? So this question, definitely difficult. Get used to plugging the compound angle formulas. Okay, what about this one? What is the approach? Any ideas on how to do this? You have done this, right? Have you solved trig equations? Which, as in like the quadrant? We don't know yet which this quadrant is going to be in. In order to draw it out, we're gonna need at least the dimensions of the triangle. So here's how you're gonna do this. Um, solve for x. Let's focus on the equation. How do we solve for x? Subtract 3, right? Negative 3, divide by 2. Negative 3 over 2. Now you have a hint of which quadrant this is in. If you look at the CAS rule, sine is negative in which quadrants? 3 and 4 is right. So you're in this quadrant, you're in this quadrant. I don't know if sketching this is gonna help much, because this is an exact value. Sine from the special triangles, sine 60 or sine pi over 3 is root 3 over 2. This is from the special triangles. So maybe I will sketch this out. So we know we're in 3 and 4. We're here, and we're here. The related acute angle is pi over 3. So those are your two alphas. So as you can see, there are two answers to this question. One answer, the angles in Q3. One answer, the angles in Q4. For Q3, what's the answer? We're looking for the big angle, by the way. We're looking for this angle. And then we'll be looking at this angle for the next one. We're in quadrant 3. If the acute angle is pi over 3, what's the principal angle? Remember, there's a pi. Yeah, exactly. Pi plus pi over 3. Take LCD, and it becomes 3 pi plus pi over 3. Becomes 4 pi over 3. What about in Q4?
It's 2 pi minus pi over 3.
Yes, 2 pi minus pi over 3 is right. So that is 6 pi minus pi. That'll become 5 pi over 3. And there you go. Those are your two answers, Q3 and Q4. This is a very common question. Let's complicate things. Let's say this value was some weird mumbo jumbo. So let's see, that's what we got. Instead of getting like a nice angle from a special triangle. How do we solve it then? What changes? Well, what changes is that the acute angle now you have to get it through a calculator. We knew the last time the acute angle is pi over whatever, 3, because it was an exact answer from the special triangle. But now this is not an exact value. This is some random number. So you have to get your acute angle from the calculator. Again, you're in quadrant 3 and quadrant 4. Not much changes. Your acute angle is going to be different now. So what you do is you're going to do sine inverse of 1 over 3. Acute angle is always going to be positive. So sine inverse of 1 divided by root 3. Unfortunately, that is not possible. What's 1 divided by root 3? Why not? Let me try that again. 1 divided by root 3. Sorry, I pressed something else. So this, I'm going to plug this in a calculator. That gives me my acute angle is 0.615. I got that from my calculator. So I know that this angle is going to be 0.615. And it's not in terms of pi because it's not an exact special triangle angle. We're still in radians. And this angle is going to be 0.615. So now what's the angle in Q3? How did we do last time? It's the same idea. Last time we did pi plus pi over 3, right? Now we're going to do pi plus what? Yes. Yes. And then just plug that in a calculator. Pi plus pi, you'll get some number, 3.75. And then in Q4, it'll be 2 pi minus 0.615, whatever that is on a calculator. So that's how you solve it if it's not a special triangle angle. All right, let's call it there for today. See ya.